Plant distribution and plate tectonics. The theory of plate tectonics holds that the Earth's crust is comprised of numerous large sections, or plates, which are in constant movement and are pushing against or pulling away from one another. Related to plate tectonics is the theory of continental drift, the notion that millions of years ago, all of the world's continents were joined as one massive supercontinent and then later slowly drifted apart, until they reached their present-day positions. Although continental drift is nearly universally accepted today, this was not always the case. When German scientist Alfred Wegener first proposed the theory in 1912, the idea was scoffed at by other scientists, especially since Wegener provided little proof of this theory at the time. Gradually, however, over the next few decades, more and more substantial evidence emerged that appeared to prove Wegener's theory. Among this evidence is the fact that certain species of fossilized and living plants have been found on widely separate continents. This seems to be solid evidence that these continents were once joined sometime in the past. As an example, fossils of the fern-like plant Glossopteris, which appeared roughly 300 million years ago, have been discovered in places in South Africa, Australia, South America, India, and even Antarctica. Geologists believe these places were all once connected as part of the supercontinent Pangaea. A seed-bearing tree, Glossopteris was one of the dominant plants of its era and lived on the Earth for almost 50 million years. Approximately 135 million years ago, when the first flowering plants appeared, Pangaea had already divided into two very large continents. The southernmost one, dubbed Gondwanaland, contained parts of all the lands that are in the southern hemisphere today. Modern plants common to these lands are descended from plants that existed 135 million years ago. The best example is the cycad plant family. Containing around 185 species, cycads are currently widely distributed in these southern lands. For a long time, this widespread distribution of both Glossopteris and plants belonging to the cycad family baffled botanists, since these plants had no means of distributing themselves across vast regions of land. Plants typically move to new territories by distributing their seeds, which they accomplish in three primary ways. First, animals such as birds consume seeds, move to new lands, and defecate the seeds onto the ground. Next, the wind picks up seeds and carries them away. Last, seeds can float on water and drift to new lands. In all three cases, when the seeds reach a new spot, they get buried in the ground, whereupon they germinate and then grow into mature plants. However, none of these methods seems possible for the cycad family. These plants produce large seeds that birds cannot consume and carry to other lands, nor can the wind easily pick them up and carry them through the air. In addition, most cycads grow far inland away from coastal regions, and, even if they grow near water, most of their seeds are too heavy and therefore cannot float on water and drift to new lands. The Glossopteris seeds were also quite large, so it appears unlikely that they could have been carried to so many regions located thousands of kilometers apart if the continents had been in the same positions 300 million years ago that they are in today. Therefore, most scientists have concluded that plate tectonics and continental drift are the only realistic explanations for the widespread distribution of these plants. The preserved remains of a plant or animal.